Oh, did that work? Hello? 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 I wonder if this is working. Hi. I'm trying to test something, and I'm wondering if it works. I don't even know if I can hear anything. Let's see. Whoa. Sorry. Okay, so what we're doing is we're reading the Abacus. Hello, everybody. Hi. So what we're reading is the Abacus, and what we're doing is we're going to count 1, 2, 3, 4, and then 5. I hope you guys can hear me. 5, 6, 7, 8, 9. So this is 9. Anytime the horizontal beat, this is a horizontal bar. Anytime the beats are touching the horizontal bar, this is considered counted. Because this is considered counted, none of these are touched. None of these are touching the horizontal bar. So that means that the horizontal bar is tracking. This is tracking. So when it's tracking, I can't hear it. When it's tracking, this is 9. We have 5. All the top beat has a value of 5. So we have 5, 6, 7, 8, 9. And then we have 10. So because we have 10, we can see what we're doing. But yeah, I don't think I can hear anything from here. Sorry. So, what's going on? Yeah, so let me know if you have any questions. Hello, hello, hello. So what we're doing is we're counting on the abacus. 1, 2, 3, 4. And then this is 5. All the top beats has a value of 5. Because this is 5, we have 5, 6, 7, 8, 9. Because this is 9, then if you notice, this is 10. Notice that the 10 and the 1 looks very similar. So what does that mean? Well, if we talk about our place value, every column is a place value. Because every column is a place value, I have this. So if you see, I have my ones, my tens, my hundreds, my thousands, my 10,000s. Because I have my ones, my tens, my hundreds, my thousands, and my 10,000s, I can have this as 1. So if you notice, this looks very familiar, doesn't it? It looks very similar. But the difference is it's on a different place value. It's in a different column. So this is my ones, this is my tens, this is my hundreds. So if I did this, this would be 100. So if I did this, this would be 10. And then if I looked at this would be 5,007. So the top beat has a value of 7 no matter what. The top beat has a value of 7, so when we look at it, we have 5,000, 0, and then 7, 5, 6, 7. I wonder if that's going to work. Okay, so does anybody have any questions? Hello, Dr. Lady and Airy and Cayupi. Yes, an apple orange. Okay, so what we're going to do is we're going to read the abacus. To read the abacus, we do 1, 2, 3, 4. So what I'll do is I'll write it out. So if I look at it, this is 4. So just as I have here, that would be 4. And then, hello everybody. How do you multiply with this? How do I multiply? Okay, we could do about multiply right now. If we know how to read it, do you know how to read the abacus, then we'll know how to multiply. So since you're the only one that's commenting, we will do multiplication. So the first thing we're going to do is understand when we multiply, we have to find our starting points. Yay, multiply. Hey, Melinda. Good evening. Good evening. I'm hoping you can hear me. You can hear me, right? Because I'm trying to do something different. I'm trying to do something different, and I'm not sure if this is working. Sorry. Share screen. Okay. So then I do my window, this one, and then share. I don't think I'm doing it right. Okay, sorry. So what are we doing is we're going to do multiplication. We do multiplication. Notice that in Abacus, we don't memorize our numbers. We don't memorize anything. We don't go anything above 12. So what we need to do is we need to understand 9 times 9, right? We know our multiplication fact, right? This is 18. Well, we can hear you well. Okay, good. I'm trying to stream on StreamYard, but I don't think StreamYard's doing my... Anyways, so what's going to happen is... Okay, okay, sorry. So let's do 23 times that by 8. So the first thing we're going to do is we need to find our starting point. 1, 2, 3. To find our starting point, we have to count our digits. We have 1, 2, 3. We're adding all these digits. This is the digits, so we're going to start here in the third column. So that means I'm going to start at 1, 2, 3. Caillou, do you understand? I'm just making sure if you're still around. So what we're going to do is we're going to multiply. Okay, so why are we going to start here is because we want to know where our starting point is. We want to know where our starting point is because we, in Abacus, we don't do ones first. What we do is we do the outside in. So we do the left first. So the first thing we're going to do is 2 times 8 is equal to 16. So I had 1, I had 6. And then I have 3 times 8 is equal to 24. 24. So I have my 2 and I have my 4. And then that's it. Yeah, I don't think I can hear. Okay, sorry. So that's it. That's all we're doing. That's multiplication. Because that's multiplication, then what we're doing is we're just adding the beads. Does that make sense? So as long as you understand how to add the beads, then it'll be easy to it will be easy to understand how to do it. Yeah, it's super easy. Super, super easy. You just need to know your stuff, right? So let's do another one. Let's do, I don't know, give me a one. Let's do another one. We can do, okay, we'll do this one. We'll do 30 and then times up by 5. So it's the same thing. It's the same thing. What are we going to do? We're going to find our digits. 1, 2, 3, 4. We're going to add our digits. That's all we're doing. So our digits, we got to start at the column, right? At the fourth digit. So we do 1, 2, 3, 4. The first thing what are we going to do? What are we going to do? What is the first thing we're going to do? The first thing we're going to do is 5 times 10. 5 times 2. 5 times 2 is 10. 1, 0, right? 5 times 2 is equal to 10. Remember there's a 0. Because there's a 0, we have to do 1 and a 0. Okay? Then we do 5 times 5. 5 times 5 is 25. Add 2, add 5. And then 3 times 5 is 15. What do we do? 1 and then 5. Easy? Yeah, easy. Let me know if you have any questions. Why do you count from the fourth and... Oh, because this is my ones. So if you notice my indicator, this is my ones. So I do ones, tens, hundred, thousands. So when we did it, when we were doing it, so the first thing we need to understand is our place values. Ones, tens, thousands, hundreds. Ones, tens, hundreds, thousands. Now, when we do multiplication, we need to count our digits. That's all we're doing. So when we count our digits, 1, 2, 3, 4, that's why we start at the thousands. 1, 2, 3, 4. Yeah, but see, that's the thing. This is our ones. This is our decimals. So just as our decimal here, this would be our tenths and our hundreds. So anything after the ones, so you could choose this one or you could choose this one. But thank you, Funnerals? Thank you, Funnerals, for the comment. Yes, let me know if anybody has any questions. Please speak up. If you don't have questions, I won't know how to answer it. Hey, Beal, welcome back. So yeah, let me know if you have any questions, because if you don't have questions, then I won't be able to I won't be able to unblock you. So let me know. And so what's going to happen is, see, I wonder, no, that's not going to work. No, whatever. No? Okay, sorry. So, I'm sorry. Iliano says 1,265. Yes. So do you count the beads in order? Do you count the beads in order at the end? Yes. I would count the beads. Give math problems. Yeah, or give a math problem. Do another one. I missed the beginning. I have no clue how to equate to the 15 apparently. Oh, okay. So the first thing, BFODEV, the first thing we need to do is understand how to read the abacus, right? So when we read it, we do 1, 2, 3, 4. And then, because this is touching the horizontal bar, this is 4. Now, how do we do 5? Because this is touching the horizontal bar, this is 5. So this is 5, 6, 7, no, 7, 8, 9. Because this is 9, we have 10. Notice, just like our place values, ones, tens, hundreds, thousands, 10,000, we have 10. So look at it's the same, right? 10, 1 and 1, 1 and 1. It's kind of the same, but the difference is the place value. Does that make sense? So when we do it, we said 15. So 15 is 1 and a 5. This is 15. Just as how we write. Just as how we write, we do 1 and then 5. Does that make sense? Yeah, yeah. So exactly how we read is exactly how we write. So the question was, so the answer was 1,265. 65. So we do 1,260, 5, 6, and then 5. So when we look, 1, 1, 2, 5, 6, and then 5. Yeah? Does that make sense? Oh, I missed that part entirely. Oh, this is incredible. Thank you for explaining this. Yeah, not a problem, B. I have a B. I know a J. I wonder if I have an A and a and an M. I know an M. So, Nathan Soup. Nathan says, how do you do this? Let me show you. Okay, let me write it. 4, 8 times that by 23. All right. Hi, hey, I've been so busy today. I can't wait to decompress with Abacus. That's funny. That's funny. I'll be M. Yes, you'll be M. I will call you M. Funny. I actually wasn't thinking about going live because I was really tired. I took the boys to go snowboarding. We snowboard over at Mountain High, which is a local area. Okay, what are we going to do? The same thing we're going to do. Okay, what's the thing we're going to do? What do we do? Do we remember what's the first step? What's the first step? The first step is to count our digits. 1, 2, 3, 4. That's it. So we know we're going to be in the fourth column, right? We know we're going to be in the thousands. So we have 1, 2, 3, 4. The last time I snowboarded, I broke my Beal, not good. Wait, you broke your ankle? That means your boot wasn't strong enough. That means your boot wasn't tight enough. Count the digits. Yes, thank you, M. Yes, Caillou, count the digits. So we do 4. 1, 2, 3, 4. So the first thing we're going to do is left to right. The first thing we do is left to right. What does that mean? We do left first. This is left, this is left. We do left first. So we do 4 times 2 is equal to 8. 8 is a single digit. So go back one column. That's what that means. Because 8 is a single digit, we want to go back to this column. That's all we're doing. This is 0, this is 8. We go back and we add our 8. Then the next thing we're going to do is 8 times 2. 8 times 2 is equal to 16. Add 1, add 6. Yeah, thank you. Thank you, M. Okay, so we're done with our 2. What are we going to do now? What are we going to do? I'm going to change color. I got to change color. That's what I'm going to do. Okay, so we're going to count again, right? We're going to count our digits. We've already finished with our 2, so we got to count the rest, right? 1, 2, 3. When we do 3, how do I know? I'm going to start here. 1, 2, 3. Now, this is where it gets a little complicated. The reason why is because we have to know our formulas. So here's a caveat. We jumped into multiplication before we started understanding our formulas. So the people that are the people that have been with me, we all know that we have formulas. The people that are starting need to understand that we have formulas that involve. I'll take it slow, but it might be a little bit much. The reason why is because there's formulas involved. So what does that mean? Well, let's start. We have 4 times 3 is equal to 12. When we add 12, we're adding 1, we're adding 2. We add 1, we add 2. We cannot add 1. So what do? Looks like foil, but 5. Yeah. Almost. So we need to add 1 here. There's not enough beads to add the 1. So we have a formula. And I got to find my little... We're adding 1. Subtracting Subtracting 2? Adding 2? No. Sorry, I'm trying to find, we're going to add the 1. We need to add the 1. To add the 1, here it is. This is what I want. Okay, what we're going to do is we're going to understand this formula. I learned the abacus in 7th grade and it helped me skip multiple math classes in each. Oh yeah, hey Loki, good. Okay, so right now we have this. Let me write the answer. The partial product. We have 9, 6, 0. Okay, so what we're going to do is we're going to add 12. We're going to add 1. We added 2. The reason why we don't have any more beads to add the 1. If we don't have the beads to add the 1, we have to do a formula. The formula is about utilizing the 10. And just as M mentioned, we are going to do is a plus 10 minus the 9. Why are we doing that? Well, in school, we are teaching children how to add the 9, how to make a 10. Making a 10 is plus the 1 is equal to plus the 10. But what we're going to do is we need to isolate the variable. This is the variable we're going to isolate. So when we do it, we have to subtract the 1. So what's going to happen is subtract the 9. We have to make 9 by itself. Oh, there's my typo. So equals 10 minus 9. We have to move this 9 over here. Does that make sense? So when we move the 9 over there, we now isolated the variable. That's the variable we're going to isolate. So then what happens is we need to plus the 10. If you look, we're going to plus the 10. Oh, no, can't do that. We're going to plus the 10. So notice I have 10. 0 and 1. I'm going to plus the 10, and I got to take away the 9. So that means I'm going to plus the 10, which just means I'm going to add the 1. I'm going to add the 1, and I got to take away the 9. I'm going to take away the 9. Then don't forget, we needed to add 2. So I add 2. So we're done with this. We're done with 4 times 3. The next thing we're going to do is 8 times 3. 8 times 3 is equal to 24. 8 times 3 is equal to 24. We're going to add 20. We will add 4. We will add 20. Okay, now what do? Well, we have to add a 2. How do we add a 2? And I had it. We have to add a 2. When we're adding a 2, we have another formula. This is how to add a 10. Again, what do? Notice in school, we're teaching children how to add a 2, how to make a 10. 8 plus 2 is equal to 10. We have to isolate the variable. To isolate the variable, we're going to subtract the 8. So we do 2, because we want to isolate this variable, equals to 10 minus 8. So when we do this, wow, thank you guys for the heart. And hey, thank you, Bill, for the heart me. So what's going to happen is now this is our formula. We have to, when we want to add the 2, that's what we want to do. We want to add the 2. We have to take away, plus the 10, take away the 8. So when we look at it, we have to plus the 10, take away the 8. So I plus the 10, I'm going to plus the 10, which just means 1, add the 1 here, and then take away the 8. I take away the 8. And then what do? I plus the 4, because that's where I'm at. So I plus my 4. So my answer is, I think that's correct, right? Your beads on the top worksheet is... Your beads on the top worksheet is... Oh, yeah. No. That's right, because I want to add 9 to 2. That's why. Yeah. Is that correct? Okay, good. Good. Because I do a lot of moving around, and sometimes the beads move. So my answer is... I'm learning my best to learn. Thank you for learning. Yeah, not a problem. So, M. The reason why this is a question. The question is 9, 5, 6, 7, 8, 9 plus 2. So this was this was a sample question. That's what this is. This is a sample question. And so then I was supposed to write it out. So that's the idea. This was to give sample questions. Yeah. So I was trying to write it out, and then I actually have a mistake here. I have to redo this one. So yeah, that's what this means. My best math skill are 8th grade math. Oh, great. My best math skill is abacus. It's just arithmetic. Okay, so that's how we do multiplication. But again, to understand the multiplication, we need to really understand how to add and subtract and multiply and divide. That's why I have to break out the formulas, because if I don't tell you about the formulas, then it doesn't make any sense. So, anybody have any questions? Yeah. Yeah, that's too bad. All right. Whew. Anybody have any questions? I wonder. I wonder. I don't know. Touch up my screen. Audio. There's no audio. What if I did? Oh, what if I did that? Nope, can't do that. Communications? Nope. Array? Nope. Okay, nope. I'm gonna do it. Can we do? I'm sorry. You explained very well. I was able to follow up pretty and never having been exposed to it. Oh yeah, fantastic, B. It's easy to understand. Can you do division this way too? Yeah, yeah, we could do. Thank you, Nathan. I thank you. I wanted to ask about division too. You want to do division? We could do division, but again, it's a little bit more complicated. I'll go slow, but just know that we still need to understand formulas, right? So there's a bunch of formulas that we need to understand. But yeah, we could do it. Not a problem. And Maureen gave me one. Okay, so the question is let me find my little formulas. Okay, so oh, here it is. Here it is. Okay, so the first thing we need to do is understand that we have divisors and dividends, right? And we're going to actually have a conversation with our questions. We're going to have a conversation with our question because we don't just look at our numbers and just do it, right? What we need to do is we need to have a conversation with our yay division. So the question is, I'm going to write it out as long division. I'm going to write it as long division because it's just easier for me to explain it. Our dividend is 39. Our divisor is that. Do we remember our dividends and divisor? So if we remember our dividend and divisor, the first thing we're going to do is we're going to find our starting point. To find our starting point, the reason why we need to find our starting point is so then we can track our answer. To track our answer, we need to make sure that we understand how to do it. So we're going to take two digits because it's a division. We have to take away our digits. So 2. So the 2 is the dividend. 2 take away 1. 13? No, I don't know. Haven't heard those terms forever. Yeah. So before we go through, let me show you how we do the abacus way. It's easy to show you on a easier question, so you don't need to, so you can see the difference. So 2 minus 1 is equal to 1. What we're going to do is we're going to start our answer here. So that means I'm going to add my dividend to the abacus. The reason why is because we're going to subtract it on the abacus. So the first thing we're going to do is we're going to have a conversation. Our S is our divisor. And then I'm going to write a chart. Our S is our divisor. That's 3. Our E is 3. Who is bigger? They're the same. So we got to go to the next number. 9 and 0. Let's pretend there's a 0 here. So there's a 0 here, right? We're doing apples to apples. We're comparing apples to apples. We're not comparing the whole digit. We're not doing all 2 digits. We're only doing 1 digit at a time. Because we do 1 digit at a time, we know what rules we need. So if the dividend is bigger or the divisor is bigger, which one is bigger? Hey, Summer Flip. Okay, our dividend is bigger. Yes, our dividend is bigger. So if our dividend is bigger, thank you, Vin, thank you, M. If our dividend is bigger, there's a rule that we need to do. Skip 1, subtract 1, or we call it eat 1. Skip 1, eat 1. We're going to skip this column, and we're only going to only take away one column. This is the one column we're going to take away. So my question now is 3 times what is equal to 3 or less? Because I want it to equal to 3 or less. So the question is 3 times 1 is equal to 3. So I'm going to add 1 to my column. I'm going to add 1 to my abacus. And then I take away 3, right? 3 times 1 is equal to 3. I take away the 3. I redo my comparing. When I compare, I have 3 and 9. Who is bigger? The 9 is still bigger. So I'm going to skip this column. Thank you, M. And I'm going to skip this column and go here. I'm going to subtract this column. So my question is 3 times what is equal to 9 or less? Thank you for the hearts. Wow, I already have 1,000 hearts. Thank you, everybody. So what's my answer? 3. 6? No. 3 times 3. This is not 6. This is 9. 5, 6, 7, 8, 9. What times 3 is equal to 9 or less? 3. Thank you, Caillou. So 3. So 3 is equal to 9. Take away 9. So my answer is 13. Thank you, Vin. Thank you, B. Thank you, M. Does that make sense? So what we did is we're having a conversation. You know how to do this. You'll know how to do all of Abacus. You'll know how to do division on Abacus. And that's the process. We do simple division so then it's easier to understand. Yeah? What if the divisor is greater? Well, let's take a look. Let me get a new page. But that's a fantastic question, Miguel. That is a fantastic question. So let's do it. So I have my little chart thingy. I must sleep now. Thank you. Okay, B. Not a problem. Thank you for the follow. Thank you for joining. Thank you for the comments. I do appreciate it. So we're going to do the dividend. So if it's bigger. Okay, let's see this. Let's try this. Sorry, I'm trying to think. Okay, what about, I don't know if this is going to work. 9, 8, 9. I don't know. 6? I don't know. Is that going to work? Let's see. Nope, that's too many. Divide that by 4. Okay, so what? Okay, so times that by. Okay, here. This is better. So 4, 9, 9, 2. There we go. Oh yeah, thank you. Not a problem. Thank you for the follow. Yep. Have a good night. Have a good night. I know it's late. I know it's really late. Oh, thank you for the hand heart. Thank you for the hand heart. Okay, so what we're going to do is we're going to do division. Again, there's a divisor and there's a dividend, right? Is that the question? What if the divisor is greater? Oh, sorry. I did that wrong. The divisor is greater. What if the divisor is greater? Let me find that. Let me find another question that's about divisor. Or do you want to do the dividend first? Let's see. We can do this one. Dividend is fine first. Okay, let's do that. Cool. Okay, good. So let's do this one first. The dividend is bigger. So how do we know? Well, again, we have our terms, right? what do we got to do? The first thing we're going to do is we have to find our starting point. So there's 3 here, 1, 2, 3, minus 1. So 3 minus 1 is equal to 2. So I go to 2, 1, 2. So I'm going to put my answer here. So that means I have to put my dividend here, 992. If you don't mind, I'd like to see this one first. I just got here. Yeah, not a problem. Dividends fine. Okay, got it. So what's going to happen? Wait, if you wouldn't mind, I would like to see this one first. Yeah. Okay. We're going to do this. So, okay. So we found where we're going to put our answer. The next thing we're going to do is we are going to compare our apples to apples, right? We're going to compare one digit to one digit. So when I look at it, I have my divisor, right? My divisor is S. That is 4. My dividend is 9. That is 9, right? My dividend and my divisor, which one is bigger? Which one is bigger? My dividend is bigger. So it's like this. So again, if my dividend is bigger, I'm going to skip one column and I'm going to eat one column. I'm going to subtract one column. Thank you. Thank you, Em. Thank you, Victoria. So I'm going to skip one column. This is the column I'm going to skip. I'm going to put my answer here. And then I have my question. Because I need to take away the 9, my question is 4 times what is equal to 9 or less? 4 times 2, correct. So 4 times 2 is equal to 8. So I do is I put my 2 here and I go here, right? It says eat one column. This is the one column I'm eating. This is the one column I'm subtracting. I'm going to take away 8. Do I have enough? Yes. I'm going to take away 5, take away 6, 7, 8. Now what? Well, my divisor is 4. My dividend, I can't look at this anymore because now it's changed. My dividend is this one column right here. So 4 or 1, which one is bigger? Which one is bigger? My 4 is bigger, correct. So if the 4 is bigger, this is where the rule comes in. When the 4 is bigger, you want to use 2 columns. These are the 2 digits we're going to use. We're going to look at these 2 digits and figure out how to subtract it. So 4 times what is equal to 19? 4 times what is equal to 19 or less? 4 times 6 is equal to 16. Yeah. 4 times 4 is 16 is equal to 16. Yep. So I take away the 1. I'm sorry. I'm going to add 4. So I add 4 here and I take away 16. Take away 1. Take away 6. Take away 5. Take away 6. So again, what's my answer? Yeah. So now I'm going to compare again because I still have dividends. I'm going to compare again. I have my 4 or I have 3, right? Who is bigger, 4 or 3? And I'm going to change another color, right? Which one's bigger? My 4 is bigger. So what's going to happen? I take these two digits, these 2 columns. So the question is 4 times what is equal to 32 or less? 8, right? Is it 8? I think it's 8. So we're going to add 8. My answer is 8, so I'm going to put 8. 5, 6, 7, 8. Take away 30, and then take away 2. Great. Thank you, Vin, Miguel, M, and Victoria. Does that make sense? So the answer is 240, not 3. No, not 9. That's it. I'm buying an Abacus. M. That's funny. Oh, you're funny, Miguel. Yeah, it's super easy, and it's this is usually for kids and stuff. But I'm in the process of trying to educate parents, and so or even people that are old, old people, because I think it helps with the brain gymnastics. Okay, so here's another question. So what happens if the divisor? I'm done with my that. I love how the example showed both cases. The divisor being greater and the dividend is also being greater. Yeah, yeah. A lot of the questions is when the divisor is bigger. So, my kid would love this so much. Yeah, how old is your child, Victoria? If I can ask. Um, it all depends. Like I'm building books. I have books. I'm building books. It all depends on how old your child is. Oh, he'd be 9. I'm in the process of creating an older kid book. But usually I would have him start doing adding and subtracting. So I wouldn't push him straight into multiplication yet, just because I haven't figured that part out yet. But that was the thing, is like I have these books that I have available, and they go into starting to understand how to do the adding and subtracting, and then once you know how to add and subtract, then we go into multiplication. But I was thinking about maybe I start with multiplication, but then I can add in, like, slowly add in the formulas. I haven't figured that out yet, but there's a bunch of books. My books are available on Amazon. That's me. Yeah. Yeah, Miguel. There's a lot of people. I mean, Beal, he bought one, and there's another one that bought. There's a few people that bought Abacus because they think it's the greatest thing next to sliced bread, and I think it's the greatest thing next to sliced bread. So, but anyways, yeah. Let me know if you have any questions. What else? It's tricky, but understanding it would be a great start. It is tricky because your child is a little bit older. I would probably recommend I would always recommend starting from the adding and subtracting first, just because we build off of it. Because multiplication is really fast addition. And so to take you through a little tour on, like, so the one thing, like, it would be easy for him to do would be to do bead recognition, right? To understand how to count the beads. So we have 1, 2, 3, 4, and then this is 5. Anytime the beads are touching the horizontal bar, it's being counted. It just clicks for some reason, right? It's really good. So, sorry, I can't wait for my abacus to come in. It just clicks for some reason. Yeah, I think so. I think because it's visible. It's very visual, and it also grows. So you can do multiplication, division, and in abacus we actually don't force anybody to mentally do mental math. You can. There's a lot of YouTube where there's like people just do a bunch of this, and what they're doing is they're doing abacus in their head, right? And so one of the things is just to be able to understand that you can visualize the abacus in your head, and you just keep doing this. But I don't. I mean, you can have your kid, go mental math. It's up to you. That's the next step, I guess, would say. For a multiplication book, you should add multiplication chart to be able to reference. Yeah, yeah, that's a good idea. Multiplication, and then I would still have to add in my formulas. So I would still be doing formulas. Oh, so Victoria, sorry. Did I finish counting? So let me finish counting. 1, 2, 3, 4. All the beads touching the horizontal bar is 4, and then this is 5. Every time, no matter what, the top bead will always be 5. So this is 5, and then we have 6, 7, 8, 9. Notice that we have this is 1, but if we look at the place value, this is actually 10, just as we write 10. So we have our ones, tens, hundred, thousands, 10,000. So a lot of it is just to understand how to read the abacus. When you understand how to read the abacus, then it'll be easy to be able to move the beads. So with this one would be 710, right? Because it's 7. 5, 6, 7. This is 1, and then this is 0. So, and then what's going to happen is, what happens after they understand how to read the abacus, they go into how to make a 5. So in school, we're teaching children how to make a 5, and that's what I was talking about in the beginning of the live. We do, like, 1 plus 4 is equal to 5. The reason why is because we want to utilize our 5. We want to make this. We don't want our what do you call it? We don't want our numbers to be freeloading. So, what I don't know about the decimals. Oh, the decimals is over here. So after the ones, is the decimal. Notice the decimal doesn't sit on a place value. It sits between the two place values. So it's just the ones and then the tenths and then the hundredths. That's it. I mean, it's really exactly the same. It's just with a decimal. So then going back to the formula, having them understand how to use the formula. So in Abacus, excuse me, in Abacus we don't memorize our doubles, which means 4 plus 4. We don't memorize this. What we do memorize is how to use the formula. To use the formula is, I want to add 2. And then my question is do I have enough beads to add the 2? No. So what do? I can utilize this 5, and you're going to see that there's a number pattern to go with it. I want to add I want to add 4. To do that, I want to add the 5, take away the 1. So my answer is 6. Does that make sense? So now understanding how to add the 4, it becomes versatile. So if I want to do this one, right, 3 plus 4. Plus 4 is plus the 5 minus the 1. It's always going to be like that, no matter what. Yeah. Does that make sense? So what's going to happen is after we do more adding, then that's the first add-in that we learn. After that, there'll be the second add-in, which is how to add a 3. And adding the 3 is the same thing. Adding the 3 is the pair is the 2. So the idea here is if I want to plus the 3, I have to take away the 2. So here is my question. 3, and I want to add another 3. I cannot add a 3. What do? I add the 5 and I take away the 2. Yeah. Yeah, it does make a lot of sense. And I don't understand, like, in mainstream math, we use all these other manipulatives, but nobody has gone back to the abacus. And I think the abacus is the greatest thing next to sliced bread. I mean, it's not the end all. Abacus is the gateway to complex math. You know your foundation, you know how to do things, you know how to add, and you also, like, understand how to calculate. Then you can go into algebra and calculus and all the other stuff. But see, the thing is abacus starts the algebra methodology or framework. Why? Because what we do, if you notice, this 3 is we isolated the variable. So that's when I started off with this here. We're going to isolate the variable. That's an algebraic term, right? We're going to isolate the variable. When we isolate the variable, then we take this and we substitute it. So what's going to happen is, if I want to do a plus 1, I'm going to substitute it, and this is where I substitute it. I add the 10 and plus the 9 and minus the 9. A lot of students don't have basic arithmetic down, so they struggle in the later years. Exactly, Miguel, exactly. And so what Abacus does is it just solidifies. We only need to know, I mean, here's the secret. We only need to know 2 sets of formulas. We only need to know 2 sets of formulas. How to make a 5 and how to make a 10. Those are the only 2 sets of formulas we need. That's it. And then what happens is, it's like Tetris. How do we fit them all together? When we know how to fit it, but don't forget, we build on top of each other. Just as we talked about this. After you learn the 5, you learn the 10. After you learn the 10, then you figure out how to mesh the 2 together. Because they play really nice together. So let's do a question. Oh, you know what? Let's do this, because I was trying to get this answered. So I'll show you what I'm trying to say. So here's my question. Let's start off with the, understanding how to do a subtraction. So what we're going to do is we're going to minus the 1. Notice when we minus the 1, here it is. Notice when we minus the 1, I'm sorry, I had a little brain fart. I want to have a 5, so I add the 5. Now notice I want to take away the 1. I cannot take away the 1. My abacus shows me I can't take away the 1. What do? Well, this is where we have our formula to play with, right? We need to utilize the 5 bead. To utilize the 5 bead, we need to figure out what to isolate the variable. So what's the variable that we need to isolate? Well, we're going to look at it. It's going to be 4 minus 1 equals to minus 5. This is the formula that we're going to be using. Why? Because now what we need to do is we need to isolate this variable. We need to isolate the -1. That's what we're trying to do. See, -1, we're trying to isolate it. So we need to isolate this. To isolate it, we need to add the 4 to this side. So that means when I rewrite the question, it'll be -1 equals to -5 plus the 4. We now know this, right? This is my formula that I'm going to do. So what's going to happen is I'm going to, where am I? Here I am. I'm going to minus the 5 plus the 4. So my answer is 4. So that's fine, right? That's the basics, right? We just want to go through and understand the basics. And so we understand that part. So let's do it again. This time it's 50. So I'm going to put 50 here. Now, oh, okay, see you later, Em. Have a good night. Take the 5 and, yeah, right? Exactly. So what's going to happen is I do 50. 50 is a 5 and a 0, and I want to take away the 10. We know how to take away the 10. How do we know? Well, when we look at it in Abacus, we only look at the column. I need to find my little doohickey. We only need to look at this column. We don't need to look at anything else. We don't need to look at 50 as a whole. We only need to look at the 5 because you notice the 1 is what we want to do. We want to minus the 1. To minus the 1 in this column is the same thing. Minus the 5 plus the 4. So my answer is 40. Does that make sense? All right. So let's do another one. We're going to do this one. 20 minus 9. Now what does that mean, right? 20. I have 20 on the abacus. I want to minus the 9. Cannot minus the 9. Well, what do? This time I'm going to utilize my 10 bead. To utilize the 10 bead, we know how to make a 10. To make a 10, what do? When I want to do a 9, so 9 minus 9 minus 1 equals to minus the 10. That's the formula. This is this is the subtraction family that we need to understand. Now what's going to happen is I need to subtract the 9. I want to subtract this 9. That's what we're trying to do. We're trying to subtract the 9. So I'm going to isolate my variable. This is the variable I'm going to isolate. So what's going to happen is I'm going to move this over here. I'm going to add the 1 to this side. So when I rewrite my question, rewrite my formula, it's minus the 9 equals to minus the 10 plus the 1. So what does that mean? That means I'm going to minus the 10 plus the 1. Minus the 10 plus the 1. When I look at it, this is 20. Again, I'm looking at only the 1 bead. Sorry, I'm looking at the 1 bead. But notice, because I want to minus the 9 here. Because I'm minusing the 9 here, I don't have any more beads to take away the 9. So what do is I use my formula. My formula is minus the 10 plus the 1. So when I look at it, I'm going to minus the 10. That means I have a 1 and a 0, right? Minus the 10 plus the 1. So if you look, minus the 10, and I'm going to plus the 1. So my answer is 11. Does that make sense? So this is about subtracting the 10. So we got that, right? Let's do another one. Let's do the final one. The final one is now what we're going to call is a two-step equation. Why is it a two-step equation? So what I was doing is I was warming us up. You know what we're doing here. We had to minus the 1, and then minus the 9. So you're making this so much more complicated than it needs to be. Brimstone, eat me out, please. If you're a spammer, I'm going to have to block you. So what's going to happen is when we do 73, right, we're going to take away 2. We're going to take away 20. When we take away 20, I disagree. It proves visually shows how the arithmetic. I love it. Yeah, thank you. I appreciate it. It also doesn't help that Brimstone is coming into the middle of a conversation, right? So here, this is where we do a two-step equation. What does a two-step equation mean? So I'm going to take away the 20, right? I'm going to look at my 7 and I take away the 20. Sorry. I'm going to only look at this column and I'm going to take away the 20. That's all I'm going to do. I'm going to take away the 20. Okay, that's fine. So look, there's a 5 here, right? So my final, so what I'm going to do is I'm going to minus the 9. I'm going to take away the 9. Again, I don't have enough beads to minus the 9. What do I do? Remember I did this? Minus the 9 equals 2 minus the 10 plus the 1. So again, we're building on our question. We minus the 10 and plus the 1. So now, before I go on, we have another thing that it's called a commutative property, which means that if I do 9 is equal to plus the 1 minus the 10, this is the same. This is exactly the same. It doesn't matter if the 10 goes first or the 1 goes first. This is a math terminology that's being used, and that was the one thing I needed to figure out. So if we look at this, it's exactly the same. So now what I want to do is I want to take away the 9, right? Take away the 9. But notice minus plus the 1. So what I want to do first is I want to plus the 1. So when I plus the 1, I'm going to plus the 1 first, and then I'm going to take away the 10. Okay, now, if you notice, I cannot take away the 10. Thank you, Beal. I want to take away the 10. So I'm back to here, this 5. Remember how to do we remember how to minus a 5? Do you remember how to minus the 5? Right? I'm sorry, minus the 1. We want to take away the 1. Right? Exactly. So what's going to happen is, and I erased it, minus the 5 and then plus the 4. So what I'm going to do is I'm going to minus the 5 and then plus the 4. So my answer is 44. Exactly, Victoria. So what just happened? What just happened is we took a two-step equation. This is a two-step equation. So the first thing we did was minus the 9 is equal to minus the 10 plus the 1. That's what we did. Oh, sorry. So then what we did, we didn't have any more beads to do this. So we had to substitute minus the 5 plus the 4. So that's why we call it a two-step equation. And then that's it. So my answer is 44. And again, it translates, because once we understand how to do a two-step equation, we can expand it to larger numbers. We can scale it to larger numbers. We just need to understand the basics. And again, it goes back to, remember, this is my 10 formula and this is my 5 formula. So now we're just building on top of each other. That's all we're doing. We just build on top of each other. And as we build, we solidify our concepts. And again, the only two sets of formulas that we need to memorize is the plus 10s and the minus I can't find it anymore. Where is it? Oh yeah, here it is. So it goes back to, we only need to memorize and understand the 10s and our 5s. That's it. That's all we need to do. It just depends on how it tetrases into each other. So, but yeah, that was one question I wanted to record, because it was just those things, like, I know people want to jump ahead, but understand the basics first. Understand how to do the basics, and then you can start tetrasing everything, right? And then you can, manipulate, modify the equation. So, does that make sense? And so it goes back to, like, the questions get harder, but it all depends on, like, I mean, people will be like, okay, well, why don't you just add 30, make it a 30, and it's like, you can, but that's not an abacus way. Why? Because there is no formula to add a 30 or to take away a 30, right? Because you still got to take away the 1. I don't know. I mean, everybody has their own way. It's just, if you want to do it the abacus way, that's how we would do it. Yeah, this is so much closer to how I do mental math. I appreciate that you went back to the basics. Thank you. Yeah, not a problem. Yeah, because, we jumped ahead to multiplication, and then, but a lot of it is, usually I start off with like understanding how to move the beads and how to do bead recognition, and then from there we can go into it. But a lot of the people were like, "Wait, I want to see what multiplication." You can do division too. I think I did division, but yeah, it still goes back down to like, what is multiplication? Multiplication is fast addition. What is division? Division is just fast subtraction. So yeah, no, I appreciate the compliments. And I also appreciate the comments. But it just doesn't help that when people come into the middle and be like, you're making it more complicated. It's like, well, if you walk into a rocket science, it's just as complicated. But if you start from the very beginning, then it's not as complicated, right? So, anyways, so what we're going to do is for those people that just came in, wow, I still have 8 people. So for those people that came in, we're going to just learn how to read. To read the abacus, it's 1, 2, 3, 4, and then anytime that the beads are touching the horizontal bar, this is counted. This is counted. These are not counted. These are all zeros. So this is 4, and then the top bead will always be 5. Because the top bead is 5, we have 6. How do I know this is 6? Because the bottom bead has a value of 1, and then the top bead is always a value of 5, no matter what. This is 5, that's 5, these are all 5s. But this is 6. So, that's 6, this is 7, this is 8, this is 9. Because this is 9, we could do 10. When we look at it, we have our place values. Every column is a place value. So this is 10. We can count by tens now. 10, 20, 30, 40, and then 50, 60, 70, 80, 90, and then 100. 100, 100. After 100, we have 200. Now I can count by 200. Now I can count by hundreds. 200, 300, 400, and then 500. Make sense? So it mimics the way we write. Now, the difference between Abacus and New Math is that Abacus keeps track of your abacus. Abacus keeps track of your numbers, whereas in New Math, they write it all out. So here was a question that they had was like, I don't know, let's do 23 times that by 40, by 4, right? So what they do is they do this. That's exactly what they do. But in Abacus, we don't need to worry about it because when we find our digits, 1, 2, 3, we keep it here. This is our digit. This is where we're going to put our answer. So if this is where we're going to put our answer, this is what I go. But in New Math, they do 20 times 4. I'm like, that gets complicated really quick because I don't know my multiplication fact that goes up to 20. So what are we going to do? We're just do 4 times 2. 4 times 2 is 8. 8 is a single digit. I go back one column, I add my 8. And then what do? Well, all I got to do is 4 times 3. 4 times 3, 4 times 3 is equal to 12. So I add my 1, I add my 2. That's it. That's it. That's multiplication. But see, the thing is I don't need to remember 20. I just remember where I am on my abacus. My abacus tracks my numbers. My abacus tracks my answers. That's all it does. You do the calculate. That's why learning the abacus is a brain gymnastics. Because we actually do the calculations in our head. We just move the beads as we need. So we have questions with our numbers. We have comments and questions, and we always ask, do we have enough? What can we do to make it enough? All right. And then that's because we have a framework. Because we have a framework, it'll be easy to see like how everything is working. That's all. So, does anybody else have any questions? Yeah. Javi, are you okay? Do you want me to go back to how to read the abacus? So this is 92. 5, 6, 7, 8, 9. And then this is at the tens place, right? Just so I have 92. So if I wrote it, if I can find my, oh, there it is. So if I wrote it, it'd be 92. That's what it looked like. That's what it is. 9, 5, 6, 7, 8, 9, and then 2. 1, 2. Yeah? Everybody's midnight mathing. Midnight math. Yeah. Okay, so what is the other thing? The other thing is understanding. I don't know if I can. I cannot unmute. Oh, I did unmute. Oh, there we go. I wonder if that works. Oh, that's all I had to do? Sorry, I'm trying to test something out. Oops, sorry. I'm trying to test something out, and I'm trying to figure out if this is working or not. Oh, this I wonder if that works. Oh, that's beautiful. All right, that does it. I got it. I got it. I got it. All right. So, does anybody have any question? This is fantastic. All right. Anybody have any questions? So, what are we going to do? We can do more questions, if that's all right. You want to do adding, or do you want to do some multiplication? We can do division, but or we can do subtraction. I think we can do subtraction. So that was the thing, right? I don't do a lot of subtraction because it gets a little hairy. So, we could talk about the book. So this is the book, and then this is the formulas that we were talking about. I was trying to make another book. I gotta change that. Okay, so, so Victoria, if you want to know more about the plus the 5, so again, we're talking about how to plus the 3, and then after adding the 3, it's plus the 2. So notice when we're doing this, we're focusing on the add-in and not the result. So I notice in school, we always focus on the result. But the thing is in Abacus, we always want to know about the add-in, and that's why we talk about the formulas. Because we talked about the formulas, and then from here, there's activities. And then these are the activities that happens, but these are specific activities for adding the 5. And that's what we're doing. We're just adding the 5. This is a color by number. And here, let's say we do 3, right? We have 3, and then plus the 1, and then we add the 4. Adding the 4 is part of the plus the 5, right? So the plus the 5 is plus the 5 minus the 1. And so my answer is 8. And so you would color that in. So I have like activities and stuff. I had it like, there's a maze. It's the same thing with the maze. You start here, and you have 3. So we have 3, and we add another 3. So notice I don't have enough beats to add the 3. How do I do it? Plus the 5 minus the 2, and then I have to add another 3. So then now my answer is 9, and I have to find which path it goes to 9. So that's all I got to do. That's what this is. And I have a bunch of mazes that do that. I'm in the process of making more mazes. Yeah. So that's what the 10. That's what the 5 is, and then there's the 10. The 10 is the same thing, kind of the same, but it's a different kind of. It's kind of different. The difference is now we're utilizing the other side, right? So we talked about how to make a 5. The next one was we're going to make a 10. Because this is a making of a 10, that's what this means. So when we do, this one is a specific activity where you have a paperclip. If I had a paperclip. So if I had a paperclip and I would spin it, right? Let me spin it. So there'd be 3. You would add 3 to this, and then again, I'm focusing on the add-in. So it'd be 3, and then plus the 7. So I have my abacus. I have 3, and I need to plus the 7. How to add 7? Well, plus the 7 is plus the 7. So this is 3. Plus the 7 is plus the 10 minus the 3. So I'm going to plus the 10 minus the 3. And then my answer is 10. So that's the thing. Yeah, thank you, Victoria. Yeah, these are the books that I've made. These are my specific abacus books. Because because we don't have it. So I'm trying to make it more interactive. I'm also trying to make it more mainstream math. And so that was the reason why I'm on this path to like try to make abacus more mainstream. And so that's why I started using like specific terminologies like isolating the variable, substitution, commutative property, and we also in multiplication we do distributive property. So this is distributive property. This one can be commutative, which means that if I add when I want to be able to manipulate the 2, so I can do 9 is equal to minus the 10 plus the 1, or, and it doesn't matter if it's this way, it doesn't matter what the order is, the answer will always be the same. So this is what you call commutative property. Yeah. So, and that was the thing, right? So in abacus world, we just say like big friends, family, whatever. But in abacus, in mainstream math, we're making a 10. We make a 10 or we make a 5. That's what we're doing. And so what I'm trying to do is, thank you, Miguel. Yes, yes, exactly. So when I have it this way or this way, then it's a commutative. And that's a thing that is, I don't know if that's taught in school, but that's one of the math terminologies that I figured out. And it's really helpful when we do it this way. It's equal both ways. Yeah, it's equal both ways. But it's interesting because abacus doesn't do this. Abacus doesn't have math terminologies. Yeah, kids learn commutative. Commutative, yes. So that was the one thing that I needed to understand too. How do I bring math terminologies to abacus? You're saying, so it's like saying 2 plus 3 is equal to. No, actually, we cannot use that. Why? Because it depends on our add-ins. So when we do it, it's actually talking about the 5. We don't do 3 plus 2 and 2 plus 3, because 3 plus 2, right? If we look on our abacus, I want to add 2. I'm going to add 2. I'm adding 2. I want to add 3. Can't add the 3. So I have to plus the 5 minus the 2, which is different than 3 plus 2. 3 plus 2, I have 3, and then 1 and 2. The term you're using is like that. The term I'm using is similar, but it depends on the number. So we can do it the same with the 5. So it can be 2 is equal to 5 minus 3, or 2 is equal to minus 3 plus 5. So yes, but no. We have to be careful with our numbers. It can't just be a free for all. Yeah, yeah. So like we have a specific set of numbers, right? These are specific math pairs. But if you bring in them 5, then it doesn't matter. It can go backwards or forwards. It doesn't matter. But like for the 10, we have, where's my, so yeah. So we have the pairs in math. We talk about the pairs, right? We do this, and I talk about it, but I don't comment that it's the same, because in abacus it's not the same, because it's always about the second add-in. It's always this add-in that we have to worry about. This is the add-in that we have to worry about. Yeah. Yeah. So, but like, oh, and then let's see, in when we do friends, or when we do making of a 10, it's kind of the same, right? And we kind of say it's both the same, but we have to be careful in abacus because it's always the second add-in. But these are the pairs for the 10s, and so what we do is we do borrowing, carrying on, trading, regrouping, and grouping. That's the mainstream math terminologies. But in abacus, we just call it plus the 10. Plus the 10 minus the 10. That's it. Yeah. It's really quite interesting on like the similarities and yet the differences between the two. And there's very subtle. There's very subtle, but I want to be specific about it because I don't want confusion with what we're trying to do. Yeah. So yeah, I gotta write that out too. There's a lot of things that we're doing in abacus that's very similar to mainstream math. It's just, trying to structure it to work with mainstream math has been one of my goals, and so hopefully I can do that. Hey, Jose, long time no see. Welcome back. Welcome back. Yeah, so those are some of the things. Let's see. we were just talking about, oh, my little contraption. I made a little contraption. I don't know if you're here for that. So here we're doing like 74. And let's say I want to add the 9. And to add the 9, I plus the 10 minus the 9. No, if I want to add the 9, I have to plus the 10 minus the 1. Oh, I need to plus the 1. I need to plus the 1, but I need to I need to minus the 10. No, I want to add the 10. So here, let me do that. Let me do that. So the question is 9. So we do 9, and then I want to add another 9. There's not enough beats. So what do? I plus the 10 minus the 1. So I have to plus the 10. So plus the 10. Plus the 10. Take away the 1. Yeah. Yeah, not a problem, Victoria. Math at night. Yeah, midnight math. Thank you, Beal, for sharing the live. Yeah, let me know if you have any questions, Victoria. And let me know if you have any questions. I'm all about Abacus and clarifying how it works with mainstream math. And there's a lot of people like ask, do they get confused? Do the children get confused? I'm like, no, the children don't get confused. They know how to do multiple things. And one of the things that they'll see the similarities and they'll be able to use it. The only thing that my kids had a problem with is that they had to show their work. They hated it. Oh, all right. So the question is 12 times 2. Ah, that's too easy, Jose. Come on. Come on. Okay, so what are we doing? We're going to count the digits. So we have 14 times that by 2. Now remember, when we do it, we have to understand where our numbers are, right? Students are adamant about not showing work. Yeah. Yeah, that's the one problem about that, Miguel. Like my kids, the same thing. And I said, no, you have to show your work. No matter if it's the way the teacher says it or it's the Abacus way, it doesn't matter. You have to show your work. So I tell them that, and I usually put Abacus as a backup. If you don't understand it, then use the Abacus. So like my kid's in 6th grade, and they're doing decimals, and he gets a little bit like tripped up in his head. And I was like, you know what? Just break out the Abacus, and so we can do it. And it's, and then he's like, oh right, and it's just different because you could see it. So here I'm going to count 1, 2, 3. I need to count 1, 2, 3. And then what I'm going to do is I'm going to times. 2 times 1 is equal to 2. 2 is a single digit. So what happens? Well, if we look at this, we can say 2 looks like that. If we made 2 a double digit, so it'd be 0 and a 2. So we're going to add 2 here. And then we do it again. 2 times 4. 2 times 4. 2 times 4 is equal to 8. 8 is a single digit. Again, I'm going to go back one column and I add my 8. And that's my answer. 28. Oh, excuse me. 28. Question mark just joined. Hey, Eon. Aeon. Aeon. I really like that movie. Javi, can you do? Of course I can. Remember, it's all the same concept, right? Remember that it's still the same still the same steps. So it's 48 times that by 2, and then we'll do the next one is 32 times 6. We'll do that. Okay, so the first thing we're going to do is count, right? The first thing we're going to do is going to count. 1, 2, 3. So we count 1, 2, 3. Now what do? We do 2 times 8 is 16. So 2 times 8 is equal to 16. I add my 1. I add my 6. Then what do? 2 times 4 is 8. 2 times 4 is equal to 8. 8 is a single digit. So I go back one column, I start 8. That's it. So what's my answer? My answer is 1, 6, 8. So you started the third column because there's 3. Yes, correct. Yes, exactly. So I mean, it's the same way. Okay, so let's do this one, and then we can do a 4-digit one, right? So again, the question is how many digits do I have? I have 3. So 1, 2, 3. So 1, 2, 3. 6 times 3 is equal to 18. I add my 1, I add my 8. I put my finger here. 6 times 2. 6 times 2 is equal to 12. Yeah. Okay, good. Great. Let's do it one more step. So we add 12. We add 1. We add 2. My answer, what's my answer? My answer is 192. That's my answer, right? So let's take it one more step. Let's do 2 digits. 2 digits times 2 digits. 192. Yes. Right? Where am I? Okay, we'll do this one. 64. 64 times that by 53. Okay, that's even better. We'll do that one too. 1312 times that by 22. So again, what are we going to do? What are we going to do? We got to count our digits. To count our digits, we have to count it all together, right? So 1, 2, 3, 4, 5, 6. I got to use a bigger abacus, Jose. All right, there's my bigger abacus. It works the same. I just don't have enough columns. 1, 2, 3, 4, 5, 6. Right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the first thing we're going to do is we're going to do our left side first. We're going to do left. What does that mean? We do this to this, right? 2 times 1. So again, 2 times 1 is equal to 2. 2 is a single digit. I go back one column, I add my 2. Now, in comparison, missing the color coding. In comparison, new math is this. 1,000 times that by 20. Now, why do we do it now? Why don't we do it this way? Because I already have it here. 2, 0, 0, 0, 0. So it does it for me. I don't need to do it. Right? I don't need to write it out. So new math writes it out. So the next one is 6 times 2. 3 times 2 is equal to 6. 6 is a single digit. So I go back one column and I add 6. Whoa, I add 6. And then I do it again. 2 times 1 is equal to 2. 2 is a single digit. I go back one column. 2 times 2 is equal to 4. 4 is a single digit. I go back one column and I add 4. So again, this gets really unruly, right? Because we have so many digits, we would have to do 300 times that by 20, and then 10 times 20, and then 2 times 20. That's really complicated. Okay, anyways. So back to abacus. We're done with that one. We got to reassess. And I'm going to change color because I like colors. We're going to do purple. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So what's going to happen? 2 times 1 again. 2 times 1 is 2. I go back one column, I add 2. 2 times 3 is 6. 6 is a single digit. I go back one column and I add 6. 2 times 1 is equal to 2. 2 is a single digit. I go back one column. I need to add 2. I cannot add 2. How do I add 2 to 4? 2 is equal to plus the 5 minus the 3. So I plus the 5 and I take away the 3. And then 2 times 2 is 4. 4 is a single digit. I add my 4. So my answer is, what's my answer? My answer is 228, 86, 4. That's my answer. So does that make sense? So what did I do is I needed to count my digits. And it's the same process. Doing multiplication is the same process. 28. Yes. Thank you. Thank you, Jose. So, but yeah, it's the same process. We just count. Oh, good. Thank you, Javi. So we count the digits, right? In multiplication, we count the digits. We add it together. So that's why we have 6. It doesn't matter. You could do it for 4. You can do it for 8. It doesn't matter. You just need to be able to count it all. Oh, thank you for the heart me, and thank you for the rose. Ah, I do miss the colors. There's a bigger one that's a 13 column one, but I don't know. Okay. Okay, let's do. Oh, no, not gonna lie, you lost me there, but I got it. But I got it towards the end. Oh yeah, question about the bigger abacus. Yep. What about the question about the bigger abacus? What about the bigger abacus? Oh, so yeah, Victoria. It's because it's a double digit. We should. That's the reason why. I just went fast. I should have went slower. I'm sorry. My apologize. How far does it doesn't matter how far it goes. It goes as far as you want it. So if you choose to be this as your ones, then you have 12 columns to be your decimal. If you choose the middle one to be your ones, then you have 1, 2, 3, 4, 5, 6, 6 columns. You have 6 columns to be your decimal. It doesn't really matter. How long does it take to do this mentally? Thank you so much. I'm having to get to an abacus to do it at the same time. Oh yeah, you're welcome. Emery, it depends on how it depends on it depends on how often you're going to practice, right? If you practice it day in and day out, you can get there really quick. Do I do it? No. Do I want to? I don't. It's not my main thing that I want to do. Can I do it? If you push me, but I wouldn't. I wouldn't bet on it, and I don't. I don't. I like to be part of my working memory because I'm trying to teach everybody else how to do it. You could do it. Do my kids do it? They can do part of it. I don't know. I think mental math is a little bit overrated. How does this work? I heard this, but I never learned it since okay. So, Aeon, before we continue, I'm going to do this, but before we continue, I want to make sure Dosi to read the abacus. So the first thing we're going to do is read the abacus. We have 1, 2, 3, 4. Anytime the beads are touching the horizontal bar, this is considered 4. So when we have 4, this is 5. The top bead will always be 5. Can I be done with division? Yeah, it can be done with division. We can do division after this. Well, we can do division after multiplication. So, dose, we have 5. This is 6, 7, 8, 9. And then we have 10. 10, 11, 12, 13, 14, and then 15. Does that make sense, dose? So when we look at it, we have our place value. Every column is a place value. So because I have this, I have my ones, my tens, my hundreds, my thousands, my 10,000. So every column is a place value on the abacus, just like how we write. Okay, if dose is not around, we're going to go on to doing multiplication. Because some people come in. Oh, you're still here. Oh, okay, good. So what we're going to do is we're going to understand that there's a decimal. The reason why I'm here is because my indicator. I have a dot indicator that tells me that this is my ones. You could choose any dot indicator like you do with Pokemon, right? You just choose one. So you could choose any one you want. I like to use this one just because I have more numbers, and then after the ones is going to be my decimals. So I have my my ones, and the decimal sits between the tenths and the ones. So I have my decimal, my tenths, and my hundreds. So Miguel was asking the question about the bigger abacus. This is a 13 column abacus. It's the same thing. The only difference is it's just bigger. That's all it is. So the only difference is now I have more choices to choose my dot indicator. I could do this one, and then I have 13 columns, or I could do this one, and I have 7 columns for my number, and I have my decimals, right? So it doesn't matter, and the colors doesn't mean anything. What it means is the place value. Every top bead has a value of 5. Every small bead, every bottom bead has a value of 1. What's the difference between the bigger one and the smaller one? More digits. Size matters. It's going to be exactly the same though, because we still have our tens, ones, tens, 100,000s, 10,000, 100,000, and then 1,000,000. So we have more digits. That's all that means. We just have more digits. So if I want to do here, right, if this is my ones, this is my ones, and notice every dot is my separator. So my ones, my thousands, my millions, billions, and trillion. Okay, well, what if you want to track the national debt? This is 13 columns. You want to track the national debt, you got to get a bigger abacus. And this is 23 columns. I got jokes. I got jokes. So again, right? Again, I have my dot decimal. My decimal is here. My not decimal. My dot indicator. Ones, ones, thousands, millions, billions, trillions, quadrillions, and I don't know. I don't know what's after that. Jokes, math, Pokemon. Track the national debt, right? I got jokes. I got jokes. So yeah. Okay. How long did it take to learn this? When did you? I learned it when I was 30, and I've been teaching for 20 years. More than 20. Now you know how old I am. It took me probably about to really understand it. Took me about a year. But I really like to understand what I'm doing. So when it was presented to me, it was just like, memorize these things. And I'm like, well, why am I memorizing? Do you live in the Midwest? I thought I heard Minnesota accent in your jokes. Yeah, no. I'm in California. I actually grew up in Toronto. So, so my dad, what happened was my dad went on a business trip. And one of the moms was like, you know what, you should bring Abacus to America and teach everybody how to do it. And he's like, this is the greatest thing, but he never learned. Whatever. He forced me and my brother to learn, and we're like, this is retarded. Why are we learning this? But as I gone through more and understanding about Abacus and stuff, I got really excited about it because I wished I learned this when I was young, but we never did it. Toronto accent is woo, California. Yeah, I'm in Southern California. I'm in LA. I thought I heard a Canadian when I but borrow. Yeah, borrow. I still have my little twinge. But I don't say out. I don't say out. I just say out. Okay. So my brother and I know how to use the abacus, but I'm the one that went through like the whole like how do I want to make abacus more mainstream. My brother doesn't really think that abacus was all that much, which is fine. I mean, everybody to each their own. But I really like the concept of the abacus, and so that's what I've been doing, out and about. Yeah, Central Coast. Yeah. But yeah, and so I just started this whole trip on bringing Abacus to the internet. I have a learning center. My brother actually owns the learning center that's out in Monterey Park, and so there was actually a person that came on yesterday and asked more about it, and it was just one of those interesting things. But yeah, we're out in Monterey Park. So if anybody wants to go visit, I'm not there too often because I'm trying to do the internet thing. I'm trying to do the online thing. Okay. So, oh yeah, we're still back to here. Okay. So again, what we're going to do is we're going to find our starting point. To find our starting point, we're going to count our digits. 1, 2, 3, 4. Because we do 4, we're going to count it. 1, 2, 3, 4. So what are we going to do? 3 times 2. Oh, My live just been flagged for hate speech and hateful behaviors. Repeat violations would result in your live being discontinued. All right. So no more hate speech. All right. So 3 times 2 is equal to 6. 6, it's because, anyways. No. 6 is a single digit, so I go back one column, I add the 6. So 3 times 5, how do I get that? Because it's over here. 3 times 5 is equal to 15. Whoa, I didn't add my 6. There we go, 6. Add 15, add my 1, I add my 5. And then I have 3 times 4 is equal to 12. So I add my 1, and then I add my 2. And that's it. Abacus slender. Yeah, no abacus slender. Yeah. Maybe. I don't know. Oh, maybe it's because I did use the art. Oh, I did use that. Oh, yeah. Ugh. That's the old person joke. That's the old person joke in me because everything is like that. All right. Thank you for the reminder. I have to remember to be careful with my words. All right. So my answer is, what's my answer? Flawless. I'm so old. I'm telling you. Okay. What's my answer? No, not yeah, 7. It's a 7. 7, 5, 6, 7, 6, 5, 6, and then 2, 1, 2. 6, 2. Yep, yep. Thank you. Ah, username not known 11. I meant 7. Oh yeah, that's funny. Yeah, right. All right. So, wow. Okay. Ooh, yeah, right? It makes sense. So easy. It makes a lot of sense. I'm so happy. Yeah, let me know if you have any more questions, Aeon. Oh, like your name. Your name has 4, right? It's 6, 6, 8, 7, 4. So yours is 47,866. I'm laughing. Oh, yeah, that's fantastic. Ah, thank you for the heart, Javi, and the heart me. Right? It's fun. It's a lot of fun if you're open to it. That's the thing, right? It's a lot of fun if you're open to it. And what it is, it's a lot about really brain gymnastics. And so I do like it, and I do think about abacus often. But my thing is to try to figure out how to. Yeah, we could do division. My thing is trying to figure out how to relate it to mainstream math, and that was the one thing. The one big thing for me is like, talking about like the dividend and the divisor and all these things, and then even like substitution and quotient, not quotient, substitution, isolate the variable, two-step equations. Two-step equations very common in algebra, so it's very interesting to come, going through this route, like trying to make it more mainstream. This has been great. Love the content. I will definitely join your lives. Oh yeah, fantastic, Miguel. I hope so too. I hope your kids will. I live vicariously through my children, so they know abacus. Do they like it? No, they didn't like it so much, but they do appreciate it. Right, another abacus for Morgan, and then division. Okay, let's do multiplication. You want to give me a number? Abacus, abacus life. Do you want to give me a abacus question? Do you want to give me a multiplication question, or do you want me to find one? It doesn't matter. Because multiplication is easier than division. Division, I have to find questions because there's certain questions that happen. We're gonna do this one. Okay, we'll do this one. 5, 3, 2 times that by 8. So the first thing we're gonna do is we're gonna find our starting point. 1, 2, 3, 4. How do I know? No, I thought you were done. So I was asking if you do another one, but division is fine. Oh no, that's okay. We can do multiplication and then we'll do division. So, Morgan, do you know how to read the abacus before I continue? And sometimes I don't get all of the comments, so that's why it's good that we can talk about it. Oh yeah. Do you know how to count it? So let's count. The first thing we're going to do is we're going to count on the abacus. We have 1, 2. Hey, Angry Birds. So here we're going to do 1, 2, 3, 4. Whatever bead is touching the horizontal bar is being counted. So that means that we have 4. If you notice, we have 5. After 5, right, all the top bead. Hey, Kim! It is after midnight. Okay, so what's going to happen is we have 5. This is 5 and then 6. Anytime the horizontal bar is touching anytime the beads are touching the horizontal bar, it's April net. Where the I know, right? I can't believe it. I can't believe it. 6, 7, 8, 9. So when we have it, we have 9, and then this is going to be 10. Now, yeah, first quarter, we're into the second quarter already. So now what we're going to do is if I look, the way I have every column is a place value. So I have my digits, 1, 10s, hundreds, thousands, 10,000. So here, when we count the digit, and then mark your place. Yeah, but I'm going to I'm going to read the abacus first because Angry Birds didn't know how to read it. So we have 1, we have 2, this is 21, this is 321, and then this is 4,321, and then this is 54,321. Angry Birds, does that make sense? Morgan, are you okay? Did that make sense? Before I go into multiplication. Yeah? Okay, great. Okay, great. Okay, good. Okay, so that's about, it's always, the coolest thing about it is we need to understand how to read the abacus. Once we understand how to read the abacus, then everything else is gravy. So just as Kim mentioned, we need to count our digits. So we're going to count our digits because this is multiplication. We're going to add our digits. We have 1, 2, 3, 4. So we're going to start here because I use this dot indicator as my ones. 1, 2, 3, 4. This is my dot indicator. This is where I'm going to put my ones. So when I count it, 1, 2, 3, 4. So here I have my 4, and I'm going to do this. 8 times 5. That's what we're going to do. The reason why is because that's why we count it out, right? So 8 times 5 is equal to 40. I add 4 and add my 0. And then what do? I do 8 times 3. 8 times 3 is equal to 24. So I add my 2 and then my 4. And then I do this. 8 times 2 is equal to 16. I add my 1. I add my 6. I add 6 here. So let me add the 6. But now I have to add the 1. This is where we have to talk about a formula. The formula is we don't have any more beads to add the 1. So when we want to add the 1, we want to add the 1. To add the 1, we have to plus the 5 minus the 4. This is a formula that we need to do. So with the formula, we have to plus the 5 minus the 4. Now, if you notice, it looks very similar to this, how to make a 5. And what we did is we isolated the variable. This is the variable we isolated, and we moved this over to here. That's all we did. So when we look at it, we do 1 is equal to 5. This is not balanced. So if it's not balanced, what do? To balance it, we need to minus the 4. Right? So that's why we added the 4. That's why we did that. Plus the 5 minus the 4. So our answer is, what is our answer? I don't know. Just joined. What is our answer? Hey, Jorge Gee. Thank you for the likes. What is our answer? $4,256. Yes. Yes. 4,256. Yep. Exactly. Yes. Thank you, Aeon. So that's what we did. This multiplication is the same step over and over again. Same thing. Doesn't matter. It doesn't even matter how big the numbers are. See, the biggest thing is just to make sure. Simple enough. Yeah, yeah, yeah. The only thing is, because we jumped ahead, we have formulas that we need to memorize, and the formulas is the fundamental. Because what is the formulas? The formulas are addition. What is multiplication? Multiplication is just fast addition. So we're jumping ahead, just so you know. It's the same thing with division. We're jumping ahead. You need to know how to do subtraction, but I'm taking it slow, so then doing the formulas is not overwhelming. But you needed to know this. This is one of the things that you needed to know, if that makes sense. This is a fundamental concept. Okay, so we're gonna do division. Okay, this one would be good. So this is now division. We have our divisor and we have our dividend. Now, just as we did with the multiplication, we added our digits. In division, we have to subtract our digits. So 3 is the dividend. We have 3 dividend digits. 3 take away 1. Does that make sense? Because we have one divisor. So 3 take away 1 is equal to 2. What's going to happen is, now when I clear my abacus, 1, 2. 2 is where I'm going to have my answer. Does that make sense? 2 is where my answer is. The second column. So what I'm going to do is I'm going to add my dividend to my abacus, because I'm going to do subtraction. So I have my 8 and 1. Don't worry about the place value here. Now we're using this as a holder. Does that make sense? Don't worry about this being saying 810, because it's not. It's 8.10. That's not what we're talking about. This is just a placeholder. Does that make sense? So using this as a placeholder, now we can compare. The first thing we need to do is compare our divisor and our dividends. The reason why is because we need to understand what we're going to do. Our divisor is 2. Our dividend is 8. Who is bigger? Our dividend is bigger. So, thank you, our 8 is bigger. So what's going to happen is this rule. There's a rule that we need to know. This rule is, I'm going to skip one column, and I'm going to eat one column. I'm going to subtract one column. That's what that means. I'm going to subtract one column. I'm going to skip one column. This is the column I'm going to skip. And I'm going to subtract one column. This is the column that I'm going to subtract. But the question now is, 2 times what is equal to 8 or less? My answer is 2 times 4 is equal to 8. So I add my 4 here. 1, 2, 3, 4. And I take away 8. I'm sorry, 5, 6, 7, 8. So now I'm left with 1. My divisor is 2. My dividend is 1. Who is bigger? Yes, my divisor is bigger. So my divisor is bigger. Now I know I'm going to be utilizing 2 columns. I'm going to utilize 2 digits. Yes, Kim. Thank you, Aeon and Morgan. Right? I'm going to utilize 2 columns, 2 digits. So what does that mean? The question is, 2 times what is equal to 10 or less? Two times 5 is equal to 10. Thank you, guys. Thank you, Bill, Kim, Morgan, Aeon. And I take away 10. Take away 1. So my answer is 405. 405. That's it. That's it. We're done. Right? So why it's a little bit more. Why? Because we actually have to do comparisons. In mainstream math, we don't compare, which I notice. In mainstream math, we say, well, how many times can 2 go into 810? Whereas in Abacus, we make it into manageable chunks. And we have rules in place if we need to do whatever. So when we compare, we only compare apples to apples, right? We only compare one digit to one digit. And that's what I noticed the difference is. And I like Abacus method when we do division. It makes sense to me. Just because we're and then these little rules that we need to understand. When we understand these rules, I mean, these are the only rule. There's a few other rules in division, but these are the main ones. Oh, I'm gonna be to see that again. Oh, I'm gonna need to see that again. Okay, let's do another one. So this will be the last one, so I can this will be the last one. How about that? Is that all right? So the question is we'll do 2 again, right? 2 divided by 416. Yeah. Yeah. I mean, I'll come on live again tomorrow. But I think this one will be the last one because I'm getting kind of tired. All right. So again, we have 3 and then 1, right? If we have 3 and 1, what's 3 and 1? 3 minus 1 is equal to 2. So 1, 2. So I know I'm going to have 4, 1, 6. Yeah, not a problem. No problem. Thank you for joining and having a conversation. I do enjoy having conversations. Okay, let's see. Our dividend and our divisor. Our divisor is 2, our dividend is 4. Definitely show up every day, Lynette rocks. Ah, ha, ha. Thank you so much, Kim. All right, who's bigger? Oh, excuse me. Yes, our E, right? The 4, yes. So what is the rule? Do you remember what the rule is? If the dividend is bigger, we're going to... What's the rule? Do we remember what the rule is? Ah, we're going to skip one column. Yes. And we're going to eat one column. We got to skip one column. We got to skip one column. This is the column we're going to skip. So we're going to be here. We're going to only subtract this one column. So the question is, do we know what the question is? What's the question? 2 times what is equal to 4 or less? 2 times 2 is equal to 4. So I'm going to put 2 here, and I subtract 4. Okay? So now, what's next? I'm going to change color. What's next? What are we comparing? We're going to compare one column. Thank you, Kim. We're going to compare one column. 2 is our divisor. This one column is our dividend. We don't want to do 16. We only want to do one column. So who is bigger? The 2 is bigger. Yes, the 2 is bigger. So that means what? That means I'm going to be doing 2 columns. So there's 2 columns, 2 digits. Because the divisor is bigger, I have to utilize 2 digits. What are the 2 digits? So the question is 2 times what? Excuse me. Is equal to 16 or less. 8. Yes, 8. So I'm going to add my 8 here. 5, 6, 7, 8. Thank you. Thank you, Aeon, Morgan, Javi, Beal. I just got here. My bad. Not a problem, Iliadio. So we're going to take away 16. Take away 1, and then take away 6. So my answer is... What's my answer? 200. Yes, 200, 0, 8. 5, 6, 7, 8. Yes, thank you. Thank you, Aeon, Javi, and Beal. Does that make sense? 208. Eladio. Oh, Eladio. Let's count. Okay, I'm gonna do one more counting on for Eladio, and then we're gonna head out because I've been here for a little bit. Okay, so Eladio, we're gonna count 1, 2, 3, 4. Good meeting you all. Probably see you sometime. Yeah, not a problem. Thank you. Thank you for joining my live. Thank you for participating. Thank you. Thank you for participating. It's really helpful when you guys participate. Thank you so much. Thank you so much for liking the live. Okay, Eladio, are you still here? Thank you, Beal. Thank you so much, Beal. I really appreciate it. So this is 4, 1, 2, 3, 4. Anytime the horizontal beads are, anytime the beads are touching the horizontal bar, it's being counted. So this is 4, and then this is 5. When we have 5, the top bead will always be 5. So we have 5, 6, 7, 8, 9. And then we have 10. After 10, if we notice, it's just like our place values. We have our ones, our tens, our hundreds, our thousands, and our 10,000. So, okay. So I don't know if Eladio is still here. I think you're still here. So when we look at it, thank you for the tiny diny. In your username, we have 481. We do 481. Does that make sense? So when we look at it, we do place values 480, 5, 6, 7, 8, and then 1. Thank you for the tiny diny, Bill. All right. Eladio, are you still here? Okay. Oh, okay. Great. So what's going to happen is if you look at it, and this will be my last little bit, that there's a decimal. The decimal happens between, I'm getting it now. Okay, great. So the decimal happens between the ones and the tenths. It doesn't sit on a place value. So if you notice, it sits between the ones and the tenths. So this is my decimal. So here's my tenths and my hundreds. But the question always comes like, why do I start here? I start here because I have a dot indicator. This indicator tells me my ones place. So I can be here or I can be here. My ones, my tens, hundreds, thousands, 10,000. If I chose this one to be my ones, then this would be my ones and this would be my 10. And then I won't have a hundreds because I only have a 7-column abacus. And that's it. So this is an abacus. And in my other lives, we'll go into adding, subtraction. You can do adding, subtraction, multiplication, division. But I'm actually going to log off. But thank you for joining and thank you for commenting. I do appreciate it. I hope to see you in my next live. Okay. Have a good night. Yeah, thank you, Beal. Thank you. I appreciate that. I'm still trying to get my book out the door. So then, yeah, I'm still trying to get that book out. I'm working on it. Right. Sweet dreams. You too. You too, Javi. Thank you so much. Okay, Eladio. Yep, I'll see you in my next live, and I will see you guys in the next live. Probably tomorrow. Bye.